On page 124, we get to the idea that we saw right at the beginning of this section. So we were hoping to get to this last class, but we didn't quite. The idea of what happens when you multiply by the same radicals in a binomial, but one of them is positive and one of them is negative. You multiply it all out, and all your square roots disappear, and you just get a number. So some things to highlight. We can highlight this definition of what a conjugate is. We can see that the reason this works out nicely is based on differences of squares. So when I do x minus y times x plus y, in other words, when I multiply two conjugates, I will get x squared minus y squared, a difference of squares. And if x and y are both square roots, when you square a square root, it goes away. Okay? Now here they've done the shortcut, but if you want, you can multiply just like normal, FOIL everything out, and you'll notice that your inside terms will cancel out. It happens every single time that you multiply by a conjugate, and then everything becomes a nice integer. So the idea is, if we have something where the bottom of our fraction, if the bottom of our fraction has a binomial with two square roots in it, and we now know that for simplifying radicals, one of the things for simplifying radicals is we can have no radicals in our denominator, we're going to have to multiply by the conjugate. So this is worth highlighting right here. At the bottom of the page. So what does that look like in an example? Well, let's go to example 4. In 4a, we have a square root on the bottom. And we have the complicated instruction, simplify. So we need to make sure we get rid of that square root on the bottom. And we can do that by multiplying by the conjugate. So I'll go 3 root 2 plus 4. And because I multiply the bottom of my fraction by 3 root 2 plus 4, I have to multiply the top of my fraction by the same thing, so that it just changes the way that it looks, but doesn't change its value. So on the top and bottom, we're multiplying. So we'll have to FOIL things out. On the top, 4 times 3 root 2. You multiply the numbers and multiply the radicals. 4 times 4. 2 root 6 times 3 root 6. Well, 2 times 3 is 6. Root 6 times root 2 is root 12. And then finally, 2 root 6 times 4. 2 times 4 is 8. Root 6. On the bottom, did I make a mistake? So I multiplied, I'll draw the arrows here. 4 times 3, 12. And then 4 times 4, 16. Then this times this, which will give me 6 root 12. And finally, this times this, which will give me 8 root 6. Same thing on the bottom. Okay? Do you want to do it the shortcut way, or do you want to just do it regular? Regular? Well, the shortcut is just, it'll be this one squared minus this one squared. So the other way, I'll change my colors of arrows here. This times this will be 9 root 4. This times this plus 12 root 2. This times this minus 12 root 2. and this times this, minus 16. Do we have any like terms on the top? What's a like? Right? So when simplifying radicals, we have to put like radicals together. Are there any radicals that can be reduced to a smaller mixed radical? Or are they all in smallest terms? The 12. The root 2 I can't simplify anymore. The root 6 I can't simplify anymore. But the root 12 I can simplify because root 12, I'll just put it off to the side here, root 12 is equal to root 4 times root 3. So because of that, I can rewrite the top as 12 root 2. That I can't change. 16 I can't change. But root 12 is the same as 2 root 3. That 2 multiplies the 6. We get 12 root 3 plus 8 root 6. All over, well, this is nice that these simplify. 9 times the square root of 4 is 18. Minus 16 just leaves us with 2. Nine times square root of 4. Square root of 4 is 2. So that'll be 9 times 2, which is 18. And then we subtract 16. We'll just get 2. So now we have done all the simplifying that we can for radicals. And now we have to look at what else does simplify mean. Simplifying in fractions means if you can divide this by 2, you should divide it by 2. Do each of these divide by 2? They do. So our final answer will be 6 root 2 plus 8 plus 6 root 3 plus 4 root 6. And just make that smaller. Everybody still read it? Everybody done? Yeah. I can make it bigger again, but I'll just make it small so it's there. Let's look at B. Same thing, B. We have square roots in our denominator. So if I want to get rid of those square roots in my denominator, I'm going to need to multiply by the conjugate. So it'll be 3 root 2 minus 2 root 3. And if I multiply the bottom by that, I need to multiply the top by the same thing. Okay, you guys have 15-second head start to multiply the top out, and 15 seconds to multiply the bottom. Multiplying out the top, should have got 6 root 6 minus 4 root 9, and then minus 12 root 12 plus 8 root 18. Doesn't matter what order you did your arrows. Okay, on the bottom, you're going to get 9 root 4 and then minus 6 root 6 plus 6 root 6 and then minus 4 root 9. On the top, is there anything you can simplify? Yes. The 6 root 6 you can't do anything with. 4 times the square root of 9. That will be negative 4 times 3, negative 12. Here, 12 square root of 12 is the same as 24 root 3. Why? Because 12 is root 4 times root 3, and square root of 4 is 2. 2 times 12 is 24. And 8 root 18 is the same thing as 24 root 2. Because 18 is root 9 times root 2. Square root of 9 is 3. 3 times 8 is 24. All over, well, these cancel out. This will be 18. This will be 12. 18 minus 12 is 6. Do each of those 4 on the top divide by 6? They do, so we can keep going and simplify it further to be root 6 minus 2 minus 4 root 3 plus 4 root 2. Are any of the terms on the top like radicals? Can we combine any of them? No. So we are done. And 10 and 13, I.